Hello dear students, in the last class we were discussed various concepts of quantum mechanics and quantum mechanical model and concepts of orbital, and some few concepts are left there over. So, we will discuss that particular concepts so today in this session. And before get into that concept, so we have to once revise that actually the concepts of orbital. Okay, so let us discuss that particular thing right now. See guys, the orbital is nothing but here the region or a space which are around that nucleus where there is a probability of finding the electron is maximum, that we can call it as here orbital. So, this is the thing, and if you consider one particular orbital means, so in that orbital the probability of finding the electron is about here 95% as we know that. So, this is also one of the most important thing. And next to that, after that orbital, so atom which consists of one particular point, one particular thing, that is node. So, the nodes is the name but here, that is also a region or a point or a space which are present around that nucleus where there is a probability of finding the electron is going to be 0, that we can call it as in here node. And actually in that node there will be two types of node are going to be takes place, that is we have the two types of node actually, that will be okay, one radial node and angular node, radial node and angular node. So, node is nothing but here, that is probability of finding the electron is going to be 0. So, here the probability of finding the electron is going to be maximum in the case of orbital. Okay. So, radial node is nothing but okay, that radial node is going to be depend on that here distance from that nucleus, that is an radial node. Angular node, that is completely depends on that here angle. Okay, and here radial node, in order to find out that here a radial node which are present in particular atom, the formula will be here n minus L minus 1, and in order to calculate that angular node present in any particular atom, the formula here itself, that is L. And here this particular radial node can be depend on that here n and L value, and angular node only depend on that here L value, guys. So, this is that in the last class actually we were discussed this particular thing. Okay, yes guys, let us continue that. So, this particular concept here, suppose guys we have to know that L value for an individual orbital here. Suppose S orbital, if you can take P, D and F, so each and every particular orbital having here so specific value of L here. So, based on that L value and N value, we are going to find out here a number of radial nodes and as well as that angular nodes which are present in that a particular atom. Then guys, we have here actual formula, means in order to calculate radial node and as well as that angular node. So, then what will be that total number of nodes supposed to be present in a particular atom means, then what might be that formula, we have to know that particular thing also. So, that is why, so this is that formula only for radial node, this is for angular node. Suppose if they may ask here, so what might be the total number of nodes present in a particular orbital means, present in a particular atom means, then we should have one particular formula here, that is total number of nodes which equals to n minus L minus 1 plus L, okay, plus L minus L get cancelled, hence that the actual formula n minus 1, the total number of nodes can be calculated by the formula here, that is n minus 1. Suppose if you want to calculate only a radial node present in a particular atom means, the formula we have to use that here n minus L minus 1, and only angular node you are going to get means, then that we are going to use that particular formula, that is L. Okay guys. So guys, let us discuss some tables are there here. So, by studying that particular table, then we are going to actually get that what will be that L value and what will be that nodal surface we are going to get in any particular orbital. So, let us see that here, there is a n value that is value of L, okay, and that is number of nodal plane. So let's take that, not n value, that is orbital. Let's take here orbital. Okay, so I just have to take here s orbital, p orbital, and d orbital, and f orbital. So let's see that what will be that value of L for this particular orbital here. Okay, very important guys, and we have to know this particular, so L value for these kind of orbitals, then only we are going to get actual, so a radial node and angular node for a particular atom. Okay, so then let's go with that particular chart here. That is orbital, we are going to have here s, p, d and f, and value of L for s orbital always be 0. This is a standard term guys, so we should have to know this particular thing here. And for that, so for that p orbital, L value will be here 1, and for that value of L for d orbital 2, and value of L for f orbital will be 3. Okay, so here orbital is being an s, p, d, f, and values for L, corresponding values of L for such kind of orbital is could be like that. For s 0, for p 1. Okay, so and for d 2, and for f 3, and that the number of nodal plane means the probability of finding the electron is going to be 0 in particular orbitals generally s, p, d, f. So in such orbitals the number of nodal plane could be here the same value of L, that is 0, 1, 2, 3. The number of nodal plane in s 0, number of nodal plane in p orbital 1, number of nodal plane in d orbital 2, number of nodal plane in f orbital would be 3. Okay, this is generally for specific, means for subshells. You are going to get that actual nodal plane for a particular orbital, means suppose 1s orbital, 2s orbital, 3s orbital, like that, 1p, 2p, so sorry, not 1p, 2p, 3p, 4p, like that, 3d, 4d, 5d, so 4f, 5f, 6f. So just like that, if you want to go with that here orbital means, then only we are going to get different types of nodal plane for that, those kind of orbitals guys. So don't worry about it. So we will discuss that upcoming classes. Okay, so we should know this particular chart, have to take down. Okay, so next I am going to take here a specific orbital guys. So we will discuss that what will be that radial and angular node and total number of nodes present in those particular orbitals. So you guys have get idea, so by studying this particular chart right now. Okay, so let's take right now, that is I just have in here orbitals. Okay, and number of radial node, number of radial nodes, and number of angular nodes. Okay, so what is the formula for that number of radial nodes guys? That is n minus L minus 1. By using this formula we are going to calculate here the actual radial node present in that, so different types of orbitals, and L here, and one more table we actually want here. So I am going to rub this particular thing guys, so I have to take down. Yes, total number of nodes by using formula n minus 1. Okay, the combination of these two, this is total number of nodes. Okay, suppose let's take here, that is orbital and number of radial nodes, number of angular nodes, and total number of nodes there over. Suppose I just have here PS, DF, S. Suppose I just have 3, 4, 5, 6, 7. Guys, you just have to take any kind of particular orbital here. I am going to take down here these particular thing. So for giving example, that's why I am just going to take this one. So you just have to take any particular orbital. We are going to calculate that. So radial node and angular node. So these particular orbitals which are not mandatory, I am just going to take here for an example purpose. Okay. So let's find out in the 3p orbital what might be that here radial node, and so what will be that angular node, means how much we are going to get here. Okay, and what will be the total number of nodes which are present in that 3p, 4s, 5d, 6f and 7s orbital. We will discuss here. So guys, this number indicating here energy levels means n value. Okay, n value here indicating here, that is 3, 4, 5, 6, 7 in these particular orbitals. And L value, as we know that for P subshell L value is going to be 1, for S L value is going to be 0, for D L value is going to be 2, and for F L value is going to be 3. Okay, so with the help of these particular value, we are going to have that here. We are going to find out the actual number of radial nodes present in these particular subshell, and number of angular nodes, and number of total number of nodes. Let's discuss, guys. So 3p. So what might be that radial node present in the 3p subshell? Let's calculate. So n value here 3. What is the L value for P? 1 minus 1. Okay, so 3 minus 2, guys, 1. So let's note down, guys, here the number of radial nodes present in the 3p subshell, that is 1. 3p orbital would be here 1. So what might be that angular nodes? Angular nodes is nothing but here the L value itself here. So what is the L value for p orbital? That is 1. So 1 plus 1, guys. Suppose 1 plus 1 obviously 2. Okay. So then total number of nodes is nothing but here, actually we are going to get here 2 total number of nodes. 1 plus 1, 2. So means suppose if you don't want to calculate that radial node and angular node, you just get that actual number of total nodes, means then you just use this particular formula. Suppose he individually ask here, so what will be that radial nodes, means what will be that angular nodes, then only we should have this particular formula, guys. Okay, total number of nodes is nothing but here, that is a combination of radial node and angular node. That is nothing but total number of nodes. So if you count down here that radial node and as well as that angular node, means that is 2. 1 plus 1, 2. Then total number of nodes will be here. Formula what will be there? N minus 1, right? So n value here 3 minus 1, 2. So 1 plus 1, 2. Here total number of node 2. That's same thing. Okay. So here you just get concentrate. Okay. 4s. So in the case of 4s orbital, what might be that radial node, guys? So let's take that formula. N value here 4. L value for s orbital 0, and 1 is to be there here. 4 minus 1, 3. The number of radial nodes present in that 4s orbital will be 3. And what might be that number of angular nodes in the case of 4s orbital? 0. Obviously, why? The L value for s orbital is going to be 0, guys. So I have to take down, I am going to write here. So L value for s orbital 0, and L value for p orbital, that is 1, and L value for D, that is 2, and L value for F orbital 3. We have to know these particular thing, guys. Okay, so keep in your mind, guys, don't be neglect those value. Without those L value, we couldn't calculate here radial node and angular node. That's why those value are very much important. Okay, and let's calculate here total number of nodes, guys. So that is n minus 1 formula. N value here 4. 4 minus 1, that is 3. So that is 3 plus 0, 3. Okay, that is total number of nodes. Individually you are going to get here radial node means 3 and angular nodes is 0. Total number of nodes means combination of these two, that is 3. 3 plus 0, 3, isn't it? So let's go with that here 5D orbital. Let's calculate what will be that. So number of radial and angular node in the case of 5D. So 5 means n value 5, D value, that is 2 for D orbital, and in the formula 1 has to be there. So 5 minus 3, 2. And what will be that number of angular node in the case of 5D orbital, guys? So for D subshell, the L value is going to be here 2. So that's why 2 plus 2, 4. So let's calculate that total number of nodes means 5 minus 1, that is 4. 2 plus 2, 4. It's very simple, right? So let's go with that 6F. Okay, so number of radial nodes in the case of 6F orbital here. 6 minus 3 minus 1. So what is the 3 value here? That is L value for F orbital, and N value for 6F orbital, that is 6. Okay, 6 minus 3 minus 1 means 6 minus 4, that is 2. What will be the L value for F? 3. So 2 plus 3, 5. So let's go with this particular formula. Total number of nodes, that is 6 minus 1, 5. 2 plus 3, 5. We are going to get there directly. Okay, 7s. So in the case of 7s, the number of orbital means number of radial node, that is 7 minus 0 minus 1, that is 6. Okay, so what will be the number of angular nodes, guys, in the case of s orbital? That is 0. So that's why 7 minus 1, 6. Total number of nodes 6 plus 0, 6. 7 minus 1 which equals to 6. So this is the stuff we are going to get by using this particular chart. So suppose if they are given any particular orbital, guys, either they, I am just taken these particular, so orbitals for an example. You just take any particular thing, any orbital you can take. We are going to actually calculate their radial node and number of angular node or total number of nodes with the help of these kind of formulas. Okay, so let's take down, guys. So much more important this particular thing here. Okay, so yes, guys, so since we have come across with here concepts of orbit and concepts of orbital, so we have to know some sort of difference between those two particular stuff. Okay, so let's discuss what will be the difference we are going to get in those particular thing. So one by one we are going to discuss here. So let's take down, guys. Yes, let's discuss right now. There is difference between orbit and orbital. So what are the difference we are going to get here? So there is difference between orbit and orbital. Let's make a two column here. So we'll discuss the difference between those particular stuff here, orbit and as well as that orbital. Okay, I just have an here orbit and orbital. Yes, guys, let's go with the previous concept. Okay, orbit is nothing but, as we know that here, suppose if you consider one particular atom according to Bohr's here, which consists of an here nucleus, and around that nucleus electron that has to be revolve around a circular path, right? That circular path is nothing but here orbit, isn't it? So then what is meant by orbit here? Orbit is nothing but it is a circular path around the nucleus where electrons are revolve. So orbit is a circular path which are present around that nucleus where electrons are revolve. That we can call to be as here orbit. Then what is meant by orbital, guys? Here orbital, what is meant by orbital? So orbital is nothing but, orbital is a region or a space or a point which are present around that nucleus where there is a probability of finding the electron is going to be maximum. Okay, that we can call to be as near orbital. Okay, so orbit, which is quite different from that of orbital. When that concepts of orbit is going to be ruled out with the help of Heisenberg uncertainty principle, then that existence of orbital is going to be takes place, guys. So that orbital is nothing but here, that is a region or a space or some particular point that is which are present around that nucleus. In this particular region, what happened, that is probability of finding the electron is going to be maximum, guys. So that we can call it as here orbital. So we have come across with here number of orbitals, isn't it here? S, P, D and F. So these all are that here orbitals, guys. So let's take down that orbital is nothing but the region. We are going to have some difference between that orbit and orbital, that's it. The region or a space around that nucleus, around the nucleus where there is a probability means possibility, that's it. Okay, probability of finding the electron is maximum. Finding the electron is maximum. Yes, guys. So this is definitions wise we have so make the difference between that orbit and orbital. There in the form of their definition wise. So next we'll go with their particular shape. So how does that orbit looks like and how does that orbital is going to be looks like means? Okay, orbit is nothing but, so orbit is a circular shape. Orbit is an circular shape. Okay, because see that if you consider one particular atom means that orbit is nothing but here circular shape, right? Okay, then orbital. So different orbital having here different shape, guys. Different orbitals having here different shape. Suppose if you get here, means suppose the thing is if you go with that here s orbital, p orbital and d orbital, f orbital, means so both the orbital means those particular orbitals is going to be here, you know, that they are having different shape. Suppose s orbital is in spherical shape and d which is in double dumbbell and p is dumbbell shape, and f orbital which is quite complex, we could not get an actual shape for that particular thing. So but guys have to know that shapes, will discuss that upcoming sessions, so there will discuss in detail, okay. But we have to know right now this particular thing, that's it. Orbit is being a circular shape and orbital. So we have here 4 different types of orbital, that is s, p, d and f. These particular orbitals are having here different shape, guys, okay. So that's why orbitals different orbitals having different shape, different orbitals having different shapes. So don't worry about it, let's discuss the shape of that orbital. Next concept will be that's only, okay. S will be here spherical, okay, and p, that is dumbbell shape is nothing but here like that, okay. Next d, that is double dumbbell shape, double dumbbell in the sense like that, guys, okay. And the f orbital shape would be somewhat complex, guys, we could not get actual shape for that particular thing. And so let's go with that very next difference between that orbit and orbital. So let's take down. Next, so orbit are non-directional in nature, okay. So the third difference between that orbit and orbital would be like that, guys, that is orbit is non-directional in nature. So since it has circular shape, that's why they are, you know, non-directional in nature. So we could not get here, you know, can you imagine that so if that particular orbit is being a circular shape, how do you know convey that so which particular that particular orbit is going to be oriented in what particular direction? Is it possible, guys? Never, right? So that's why orbit is nothing but here which is a non-directional in nature. So being a circular path, it has circular shape, so how it could possible in order to orient it in particular direction? Never, right? So that's why orbit is nothing but here non-directional in nature. So it's being a non-directional in nature, that's why it could not explain that here shape of the molecules. So shape of that molecules means, so you know, we have lot many molecules here, so those molecules it should have here some sort of, you know, shapes like, you know, tetrahedral shape, pyramidal shapes, pentagonal bipyramidal, so trigonal bipyramidal, octahedral, square planar. So these kind of shapes, you know, we are going to have that. So and individually, so such kind of shapes this particular orbit concept could not explain, guys, okay. So why? Because that orbit is being a non-directional, okay. So orbit is being a non-directional in nature, hence they cannot explain shapes of the molecule, okay. Say for example, see, suppose we have here methane molecule, the shape of methane molecule is going to be a tetrahedral. So how that methane molecule got here tetrahedral shape, that could not explain here that orbit concept, but it could possible only for orbital, okay. Why? Because orbital is nothing but, the thing is that except s orbital, so rest of that particular orbital is going to be directional in nature. Only s orbital is being a non-directional, and rest of the p, D and F orbitals are going to be directional in nature. That's why these particular orbitals is going to explain here shape of the molecules. Okay, so let's take that one more important difference between that orbit and orbital. Except S orbital, all the orbitals are, means rest of the orbitals are directional in nature. Okay, hence it could possible, hence that orbital, hence they can explain, hence it can explain shape of the molecules. Okay, so this particular thing you are going to have in that chemical bonding chapter, we'll discuss there over. Okay, very much important guys here. Without orbital we could not have an here a shape of a particular molecules here. Okay, so I just told you that a number of molecules are going to have, we are in our chemistry. Okay, so there lot many molecules are going to be there. So those particular molecules have different shapes, have this particular shape. So that shape can be explained based on that here orbital concept, but not on that orbit concept guys. Okay, so we'll see that because that overlapping has to be taking place in between the different types of orbital, then only there could be possibilities of forming a different shape for the different molecules. So in that chemical bonding chapter you guys are going to get in that deep form. Okay, let's discuss there over, don't worry about it, but have to get concentrate over these particular thing. Okay, so last but not the least difference between here orbit and orbital would be like that. So what will be the last difference means? See guys, that orbit concept which is against of an here Heisenberg uncertainty principle, isn't it? Why? Because Heisenberg uncertainty principle that can rules out here that concepts of orbit, but that can so leads to that here probability of finding the electrons in the form of xi square, isn't it? So the thing is that orbit concept which is against of that here Heisenberg uncertainty principle, but that concepts of orbital that is accordance with here concepts accordance with here Heisenberg uncertainty principle, very much important. So these are also, that is one of the most important difference between those two things. Let's take down, that is orbit is against of Heisenberg uncertainty principle. So but the concepts of orbital will be accordance with here that particular concepts of Heisenberg uncertainty principle. The orbital is accordance with concepts of accordance with Heisenberg uncertainty principle. Yes guys, so these are the major important difference between that orbit and orbital. Okay, so let's take down guys, that is nothing but here very first difference between that orbit and orbital, that is orbit, so is nothing but here a circular path, so which are present around that nucleus where there is electron is going to be revolve, and orbital is nothing but here a region or a space, so which are present around that nucleus where there is a probability of finding the electron is going to be so maximum. And second one, orbital means orbit is nothing but a circular shape, and orbital is different orbital having different shape, like S spherical, P dumbbell, D double dumbbell, and F complex shape it has. So we'll discuss that further. Okay, so next third, orbit is means that orbit is here non-directional in nature, hence they cannot explain the here shape of the molecule, and orbital except S orbital, rest of the orbitals are directional in nature, hence because of that particular thing. So those particular orbitals is For those particular orbitals, it is possible to explain that shape of the molecule and that orbit ultimately which is against of Heisenberg uncertainty principle, and orbital which is accordance with here Heisenberg uncertainty principle. So this is the major difference between here orbit and orbital, guys. So guys, next important concept will be here shapes of orbital, most important, guys. So actually we are going to get here, so what will be the shape of orbital, so what will be the shape of S, P, D and F. We could not have that proper shape, but rest of that orbital has that particular shape and some character also we are going to be discussed there over. So we will see one by one what will be the stuff we are going to get by studying those particular concept right now. So let's go with here one of the most important concept, that is shape of the orbitals. Shape of the orbitals. Shape of the orbitals. So guys, we have here 4 types of orbitals here, means S, P, D, F. Okay, so actually they are subshells. So in the subshell we have number of orbitals there over. So let's go with here very first shape of S orbital. Shape of S orbital, very much important concept, guys. So let's focus on this particular thing. See, shape of S orbital. So the thing is that S orbital is being a non-directional and having spherical shape, isn't it? So very first point here, that particular S orbital is being an non-directional in nature. Non-directional in nature, which means that the probability of finding the electron is going to be same from that nucleus. So this is the term indicating here that particular S orbital is nothing but here non-directional. And if you want to know that here shape of that S orbital is nothing but here spherical in shape. So what is the shape of that here S orbital? That is spherical shape, guys. And here S orbital is being non-directional in nature. So which means that here the probability of finding the electron is same from that nucleus. Suppose if you consider one particular atom here, let us take here S orbital is being an spherical shape, right? Okay, which is nucleus. Okay, so non-directional means you go with that any particular x axis, y and z, z dash and x dash and y dash. Okay, so this particular S orbital is being a spherical and which is non-directional in nature, which means that the probability of finding the electron is going to be same distance from that nucleus. Okay, you go with this particular direction, this particular direction, this particular direction, and this and this and this. The probability of finding the electron is going to be same distance from that nucleus. So which indicating here that is non-directional, and probably that shape of that S orbital is nothing but here spherical shape. So this is quite like that. Okay, so and one more important thing we have to know, guys, here. Yes, that here n value has to be increases, that energy and size of that particular orbital is going to be increases, guys. Very much important. Suppose as we can increases here n value, means energy level. Okay, as we can increases here n value, the size and energy of the particular orbital is going to be increases. Very much important, guys, this particular point. So let me clarify this particular thing right now. Just have to take this particular point right now here. The increasing n value, the energy and size of the orbital is also increases. So I mean to say is that suppose if you can take here 1s orbital, 2s orbital and 3s orbital. So here n value I am going to increasing. Okay, as compared to 1, 2 is to be bigger, as compared to 3 is to be bigger, means as here n value is to be increases, their energy and size is also going to be increases, isn't it? So that's why the order of this particular thing would be like that, guys. 1s which is less than that of 2s, 2s which is less than that of 3s, which means that here 3s orbital having that more energy and size than that of 2s, and 2s orbital having more energy and size than that of 1s. Okay, so then let's discuss the shape of these three particular orbital here. 1s, 2s means almost all the particular s orbital is going to be spherical, but their size wise we'll discuss there. Okay, so let's focus on this particular stuff here. Let us consider which is 1s, 1s. Let us consider that is 2s, that is 2s guys. So you just look at their size, you know. So 1s which is smaller than that of here 2s. Suppose if you want to know here 3s means just look at the size guys. Yes, I am just going to increasing here n value. Okay, so as we can increase this n value here, the size of that particular s orbital is going to be increases. Okay, so let's take here in this particular 1s orbital, n value will be here 1, and in the case of 2s orbital n value will be here 2, and in the case of 3s n value will be here 3. Then what might be that radial node present in these particular orbitals? So let's calculate that one. Radial node. So in the case of radial node, in the case of 1s orbital, what might be the radial node? So let's take formula n minus l minus 1. What is the n value here? 1. What is the l value for s orbital? Obviously 0, and 1 minus 1 0. See, we could not get any kind of radial node in the case of 1s orbital. Why? Because since here the probability of finding the electron that has to be started from here nucleus itself. Okay, that's why we are going to get here a 0 radial node in the case of 1s orbital. So one more time I am just revising you guys. So let's focus this particular point, very much important. We could not get a radial node in the case of 1s orbital. Why? Because in this particular case what happened, the probability of finding the electron that has to be started from the nucleus itself. Okay, that's why we could not get here a radial node in the case of 1s orbital. But in the case of 2s orbital we have one radial node, right? So we have that is a radial node in the case of 2s orbital 1. So if you want to calculate with the help of formula means, then go with that. Radial node which equals to n minus l minus 1. What is the n value for in the case of 2s orbital? 2. What is the l value? 0 minus 1. 2 minus 1 guys 1. So this is the radial node. So node is nothing but here what? The probability of finding the electron is going to be 0, means that is empty space is there, no, that is nothing but here node. Then what will be that radial node present in the case of 3s? Obviously here these two are here a radial node guys, a radial node. So a radial node can be calculated by the help of this particular formula, that is n minus L minus 1. What is the n value in the case of 3s orbital? 3. What is the L value for S? 0 minus 1, 3 minus 1, 2. So this is one particular node and this is 1. So total we are going to get here 2 node in the case of 3s orbital. So then look at their size, guys. So size wise, in the case of 1s orbital, that is small, isn't it? In the case of 2s, which is big, and in the case of 3s, which is biggest, isn't it? So this is the stuff we are going to have to know in the case of s orbital. So this is the stuff, guys, we have to actually know these particular concepts here. Okay, shapes of s orbital is nothing but, so s orbital is being a non-directional in nature, so it has spherical shape. So non-directional, which means that the probability of finding the electron is going to be same from that nucleus, which means that here non-directional. Okay, and as you can increase the n value, the energy and size of that particular orbital is going to be increases. So we have evidence for that particular thing there over. Okay, that's why that 1s orbital, which is less than that of 2s and 3s in that energy and size wise. Okay, so we have a proper evidence for such for this particular statement. Okay, so 1s orbital, which is lesser than that of, means energy wise and size wise 2s, and 2s which is lesser than that of 3s, and number of radial node present in the case of 1s 0. Why? Because the probability of finding the electron that has been started from nucleus itself, and the 2s orbital, the radial node is must be here 1. We have actually that proof here. Okay, and that is also 3s orbital, the number of radial node will be here 2, and size wise which is small and which is big, and 3s which is biggest. So this is the actual stuff we have to know, guys. So let's go with here shapes of d orbital. As we know that here s orbital, that is spherical in shape. Okay, let's go with that here shapes of p orbital. What are the things we are going to get in that particular p orbitals? Very much important, that is also. Shapes of p orbital. So guys, in p subshell, there are 3 orbitals are there. 3 orbital are there, that is px, py and pz. So which means that, so in p subshell, since we are studying here shape of p orbital means, so here in the case of p subshell we have here 3 p orbitals. So those 3 p orbitals here, px, py and pz. So how these particular orbitals is going to be exist means, why? Because in p subshell the L value is going to be here 1. In p subshell, for p subshell L value is going to be 1, as we know that, right? So suppose if L value is going to be 1 means that ml value that can be lies between here minus L2 plus L. So guys, these are quantum numbers, we will discuss there over, but you guys actually know that these particular stuff here in order to understand this particular thing. Okay, so nothing, don't worry about it. Okay, don't think much about it, just you go with that concept here. L value for p subshell here 1, that's why their ml value means magnetic quantum number value is going to be here minus L2 plus L, means here ml value obviously minus 1 2 plus 1. So in between value what will be there? Minus 1 0 plus 1. So these 3 values actually we are symbolically represented as here px, py and pz. Okay, so what we are going to get here for m value for p subshell minus 1 0 plus 1, these 3 values symbolically represented as here px, py, pz. So these 3 p subshells, these 3 p particular orbitals present in that p subshells, guys. Okay, and these p orbitals are having which shape, guys? Having dumbbell shape. Okay, p orbitals having here dumbbell shape, very much important, guys. So dumbbell shape is nothing but, let me tell you one particular thing. Okay, so p orbitals are having here dumbbell shape, and one more thing here, these 3 particular orbitals having equal energy. These px, py and pz, these 3 particular orbitals are having here equal energy. So that's why these three particular orbitals we can call it to be as in here degenerated orbitals. Degenerated. The term degenerated, which means that the orbitals are having here equal energy. So that's why, since here these three particular orbitals are having equal energy, hence those particular orbitals can be known as in here degenerated orbitals. So those orbitals are, those means these p orbitals in the sense px, py, pz. P orbitals are having equal energy, that's why they can call to be as an, they can called to be as an degenerated orbital. They can call to be as in here degenerated orbital. Okay, so yes guys, so this is the thing, and these particular orbitals are directional in nature. Okay, why? Because these particular orbitals are oriented along the axis. Okay, that's why these three particular orbitals are directional in nature. Let's take down and let me show you the diagram, then you guys are come to know that what will be that actual stuff here. Okay, so let's take down here the p orbitals are oriented along the axis, hence they are directional in nature, okay, and each p orbital having here two lobes guys. Okay, each p orbitals are having here two lobes, and those lobes are have been separated from here one particular nodal plane. Let me show you the diagram, don't worry about it, just focus with that particular statement. Okay, each p orbitals are oriented, each p orbitals are having two lobes. Let me tell you that what will be that lobes here. Okay, so two lobes on opposite side, and they are separated by a nodal plane. So guys, let me concentrate here. Okay, so let's concentrate here. I am just having here, okay, orbital right now, that is, let us assume, which is px. This is px orbital. Okay, so px orbital, py and pz, this is px orbital, which is x, y, z. Okay, so this is px orbital, means that is dumbbell shape, and each orbital having two lobes. This is one lobe and two lobe guys, which means in this particular portion only the probability of finding the electron is going to be maximum. So in this particular portion, okay, and the rest of the axis are nothing but here nodal plane guys. Okay, in the case of px orbital, the probability of finding the electron that has to be oriented along the x-axis, and the rest of the z and y-axis it will be here a nodal plane. Means in this particular case what happened, the probability of the finding the electron is going to be 0 at z and as well as the y-axis. Keep in your mind guys. So next thing here, okay, so this is about here px orbital. Let us take guys, which is py orbital guys, which is x and z. So in the case of py orbital, what happened, the probability of finding the electron is going to be oriented only the y-axis, and the rest of the axis z and x is going to be here nodal plane, that is py. Next have to take down So there is pz orbital, okay, that is pz and which is y and this is x, that is pz orbitals guys. So in this case what happened, the probability of any electron which is oriented along the z axis but at the rest of the axis y and x, it will be that nodal plane. So guys, as you consider here, in the case of pz orbital, the probability of any electron could be like that, means the nodal plane it must be along the, you know, in this particular, means if you consider this particular probability of finding the electron, that has to be oriented along the z axis, means the rest of the axis x and y. So these are nothing but here a nodal plane, okay. In the case of pz orbital, that is px and py are in here a nodal plane guys, but in the case of py, that is pz and px, these are nodal plane, means that x and y plane, are nodal plane here, and zx are nodal plane, okay. And in the case of yx are nodal plane, means in this particular axis the probability of finding the electron is going to be 0, okay. And each particular orbital having here two lobes which are present in an opposite direction, okay, and these particular lobes are oriented in a particular direction, hence they are directional in nature. Suppose in px orbital what happened, that probability of finding the electron is going to be oriented along the x axis. In the case of py, that is oriented along the y axis. In the case of z, that is oriented along the z axis, hence they are directional in nature, isn't it? And each p orbital having two lobes, which means that, and they are in opposite direction, and those particular lobes have been separated by a one certain nodal plane. In the case of px orbital, what will be the nodal plane? Yx. In the case of py, what will be the nodal plane? That is zx. In the case of pz, what will be the nodal plane? That is xy guys. So this is the thing, and so this is all about here shape of p orbital. So in the next section we are going to discuss shapes of the d orbital. So let's discuss day over. So thank you no doubt.